In the exercises that we just walked through, we saw how we could update a data property's value with the vOn directive and the keyUp event. We did this both using a method as our event handler and by embedding a JavaScript expression directly into our template. Not only was this code specifically handling text input fields and would therefore not handle checkboxes, radio buttons, etc., it would also become pretty repetitive. Instead of writing this piece of code ourselves, fortunately there's a better way, the vModel directive. This directive implements two-way data binding for us. Two-way data binding means that changes to a data property updates the DOM, and changes made to the DOM will update the data property. So data flows both ways, hence the term two-way data binding. Without further ado, let's see an example. As you have probably noticed, I have prepared a text input which does nothing, and a data property called name. The vModel directive takes an expression, which will be the name of our data property, name in this case. So, using the directive is as simple as writing the following. So, we'll enter the name of the directive, which is v-model, like so. And the expression is going to be the name of our data property, like so. So if I enter something in the text field, you will see that the data property is updated accordingly. Now that was easy, right? No more methods or inline JavaScript expressions within the template, at least not for accomplishing this. Something you should note is that the vModel directive will ignore anything you have written inside the value attribute on an HTML element, because the data property always takes precedence. So if I were to give the name property an initial value and add a value attribute at the same time, we'll see that the value attribute is ignored. So let me just add my name as the default value to the data property. And up here on the HTML element, I can write value equals test. And let's run the code. You might see a flicker where test is displayed in the text input for a split second before being replaced by the value of the name property. This is simply the time it takes for Vue.js to kick in. Before then, whatever is in the value attribute is displayed as per normal HTML syntax. So I'll just remove this test again. I mentioned that the vModel directive supports other HTML elements as well. While this is indeed true, this is something that we'll see later in the course when we begin working with forms. So let's talk a bit about modifiers. There are a few modifiers available for the vModel directive. The first one I'll show you is the trim modifier. This modifier does exactly what its name suggests, trims the user input. So let's apply it up here. After the directive name, I'll write .trim. And with this, any leading or trailing spaces in the input field will be removed when the value is synchronized with the data property. The second modifier I will show you is the number modifier, which ensures that the input is automatically typecasted to a number. You can think of this as the equivalent of calling the parseInt JavaScript function on the input. Let's test it out. Since we now need a data property that contains a number, I will add an age data property and use that in place of the name property. I will also remove the trim modifier. So let's do the latter first. And here I'll replace the expression with age, which is a data property that I will add right here. I'll set it to 27. To help with debugging our example, I'll output the data type of the age property. So I'll add a new paragraph tag here. I'll say type : and then use string interpolation to output the data type with the expression type of age. And if I run this example, you'll see that the data type is initially a number because I specified an integer as the default value for the age property. If I type something in the input field, however, you will see that the data type changes to string. This is because the value of a text input is always a string. If I add the number modifier, you will see that the value is casted to a number. So let's do that. I'll say dot number here. And let's see. Indeed, it still displays number as the type. And if I now type something into the input field, you'll see that the type remains a number. Typically, you would use the number input type though. With this input type, it appears that Vue.js automatically casts the value to a number, unlike with plain JavaScript. So the number modifier is not even necessary in this case. However, there may be situations where you need to use it, so now you know how it works and how to use it. By default, the vModel directive synchronizes the input with the data when the input event fires. If you want to change this to happen on the change event instead, you can do so by using the lazy modifier. So what's the difference? The difference between these two events is that the change event fires when an element's data has been changed and the element loses its focus, whereas the input event fires every time data is changed. Right now, the data is updated every time I press a key, because this triggers the input event. Now I will add the lazy modifier, so that we can see the difference. So let's go up here after the number modifier, let's write dot lazy. And let me just change the string interpolation here to be h as well. So if I start typing something in the input field now, we can see that the value is not updated. But the moment I click outside of the field, causing it to lose focus, the change event fires and the data is synchronized. In this lecture, we took a look at the vModel directive, which can be used for two-way data binding, eliminating the need for writing custom methods and expressions to handle this. Apart from being easier and faster to use, there are a few added benefits of using the vModel directive. As we'll see later in the course, the directive works with multiple input types automatically. It also handles certain edge cases, such as browser differences and such. So far, we have seen how we can use string interpolation to output data. When doing so, Vue.js actually takes some security precautions on our behalf by escaping the data. Before talking about how Vue.js escapes data, let's first talk a bit about why this is the case. Suppose that users on a website can type their name into a text field, and that this name is output on the front page of the website. If the user decided to enter HTML markup instead of his or her name, the user would be able to change the markup of the front page. This could be as harmless as entering an h1 tag, which would just affect the appearance of the page, or as harmful as embedding JavaScript code that redirects the user to a harmful site that could try to steal the user's credentials. A lot of different attacks would be possible, and therefore the safety of all of the website's users have potentially been compromised. This happens because any markup that the user enters as his or her name is unknowingly rendered by the browser and displayed or executed as if it were an intended part of the page. Such an attack is called cross-site scripting, often referred to as XSS. Such a security vulnerability can be resolved by escaping the data. This means that certain symbols are converted to so-called HTML entities, such that they are not rendered as part of the page by the browser, but instead displayed. This is exactly what Vue.js does for us automatically, so let's see that in action. I have a data property which contains a string of HTML markup. Let's see what happens if I try to output it with string interpolation. So let's just do like this and run the code. Perhaps the result is not what you would expect. We see the actual HTML markup on the page and not the header that we might have expected. This is because Vue.js automatically escapes any markup before it outputs data on the page. This is good default behavior because one has to be very careful about outputting unescaped data on a page for the before mentioned reasons. If you really do need to output data without escaping it, you can use the v HTML directive as follows. So then we just add a div element here. I'll use the v.html directive here. And for the expression, I'll write HTML. So by simply writing the name of our data property, we can output the HTML in such a way that the browser will render it as it normally would. So if I run the code, notice that we now see hello world within a header. Just a word of caution though. You should only do this if you know for sure that the data that you are outputting is safe. As a rule of thumb, if the data is from a user, then you should not trust it unless it has already been escaped. Don't even trust data that you have added to your database. Because if someone gains unauthorized access to your database and manipulates the data, then all of your users could potentially be hacked. So be very cautious about using the v.html directive and only use it if you absolutely need to and you know what you're doing. In case you have any questions about the best practices, then you're more than welcome to ask. If you, for whatever reason, want to only output something one time, then you can use the v.once directive. This directive ensures that an element is only rendered once, and when Vue.js re-renders the page, the element and all of its children will be considered as static content and thereby skipped. An example usage of the v.once directive is for optimizing the performance when updating data on the page. In the example that I have prepared for you, I simply output the title of a movie using string interpolation. And I also have a button which simply updates the movie title to a different movie. If I click the button, you will see that the text changes as you would expect. Now I'll simply add the v.once directive to the h1 element. So I'll enter it here, v.once. And the v.once directive does not expect an expression. So this is actually all we need to do. So if I click the button now, we'll see that the text is no longer updated, even though a new value is in fact assigned to the data property. This is because the h1 element will not be re-rendered after it has been rendered initially. So when Vue.js processes data changes, it will simply ignore the element. If the element had any children, these would also be ignored, even if they contained any string interpolation, for example. Until now, our templates haven't supported dynamically rendering elements based on Boolean conditions. That's about to change, as we'll talk about 3 directives in this lecture: vif, velsif, and velse. The names of these directives should be pretty self-explanatory, so let's dive straight into an example. Suppose that we have a web shop and we want to display how many items are in stock, but that we also want to display a dynamic text based on the item count. This number is stored in a data property called items in stock. Right now, we have 3 paragraph elements containing 3 different texts. We want to display the first one if there are more than 10 items in stock, and if there are between 1 and 10 in stock, we want to display the second one. Otherwise, we display the last text. As for the first condition, I can simply use the vf directive to check if the items in stock property contains a number greater than 10, like this. So on the first paragraph, I will enter vif as the directive, and the expression is going to be a Boolean expression. So I can write items in stock, which is the name of the data property, greater than 10. So in this case, the directive's expression should evaluate to a Boolean value. If the items in stock data property contains a number greater than 10, the paragraph is rendered and otherwise it's ignored. For the second paragraph, I'll use the velsif directive. This comes into play if the vif directive's expression evaluates to false. The velsif directive also takes an expression, so this time I'll check if the items in stock data property is greater than 0. So here I can write velse-if equals, and here is the expression. I'll say items in stock greater than 0. Because this is only evaluated if the vif directive's expression evaluates to false, This effectively checks whether or not the items in stock property contains a number between 1 and 10. The last scenario is if none of these two conditions are true, meaning that no items are in stock. This is as easy as adding the v-else directive without any expression. So let's do that. I'll just write v-else and that's it. Running the code now, we'll see the number of items in stock currently being printed because the number is greater than 10. If I change the item count to 8, like so, it seems like there are just a few items left in stock, so we better hurry. Changing the number to 0 will result in a text stating that we are out of stock. Awesome. Note that since the directives expect an expression, I could also have entered the name of a data property as the expression. In this case, the data property would need to contain a Boolean value, i.e. true or false, but the behavior of the directive would remain the same. Be aware that these three directives actually remove the elements from the DOM in case they evaluate to false instead of hiding them. This means that if we inspect the paragraph element that is displayed, we are not going to see two other paragraph siblings in the DOM that are hidden by CSS. So let's check that by inspecting this element. And as we can see here, there is indeed only one paragraph tag here. So the two other ones are removed from the DOM. They are not hidden by any CSS style. So the elements are removed and added to the DOM if something changes and the expressions evaluate to true. This also applies to any child elements of the element that contains the directive. Another thing to note is that the v-else if and v-else directives require that the previous sibling contains the v-if and v-else if directives respectively. This basically just means that Vue.js requires that these three directives are placed on the same level in the DOM, meaning that the elements must be siblings. So you cannot have an element with the v-if directive and then nest an element with the v-else directive at a different level in the HTML. But what if you have multiple elements that you want to be affected by a v-if directive, for instance? Say that we have two new paragraph tags that we only want to render if we have lots of items in stock. So let me just go ahead and add these two new paragraphs. I'll say special offer. Looks like we have tons of products in stock. Save 20% if you order now. So this should be displayed if we have a lot of items in stock and we want to get rid of them. So how can we only display these two elements if we have more than 50 items in stock, for example? We could wrap multiple elements within a div element, but this would also change our markup, which may be undesirable and cause you to have to use CSS to fix the appearance. Instead, you can use the template element, which was added in HTML5. Using this element means that the template wrapper element is not added to the DOM, but the inner contents are. I will add a template element that wraps the paragraphs and use the v-if directive to check if there are more than 50 items in stock. So first, let's add the template element, like so. I'll copy these two paragraphs in there and just fix the markup a little bit, like so. And on this template element here, I can write v-if equals items in stock is greater than 50. Now I'll just change the items in stock to be 51 so we can see it in action. Now the paragraphs appear, but if we inspect the DOM, we can see that there is no sign of the template element, as you can clearly see here. This is great because in this case, we don't need to use a div element as a wrapper, which then affects the DOM and potentially the appearance of the page. In the previous lecture, we took a look at the v-if, v-else if, and v-else directives. These directives add or remove elements from the DOM, depending on the evaluation of expressions. What I want to show you now is a directive that shows or hides elements in the same fashion, namely the vShow directive. This directive works the same way as the vIf directive, except that the elements remain in the DOM and are only hidden by CSS. I have prepared a simple example with 2 paragraphs and a button in the template. The Vue instance has an isNinja boolean data property, which is switched when clicking the button. What I want to do now is to show the first paragraph if isNinja is true and show the second paragraph if it's false. To do that, I can simply enter the name of the data property in the vShow directive's expression. So let's go ahead and do that. I'll enter vShow, and here for the expression, I'll just write isNinja, like so. I can do the same with the second paragraph, except that I will negate the boolean by prefixing an exclamation mark. So the same here, but exclamation mark is ninja. Note that I could also have used more complex expressions here, but these ones are sufficient for this example. Clicking the button now will switch from one paragraph to the other. If we take a look at the DOM through the browser's developer tools, we can see that the paragraph that is not shown actually has a style of display none. Clicking the button again, you can see that this style switches from one paragraph to the other depending on which paragraph's vShow expression that evaluates to false. So as you can see, the vShow directive shows or hides elements, unlike vIf, which adds or removes them. Since we are on the subject of showing and hiding elements, let's see how we can hide the string interpolation syntax that appears on the page until Vue.js is bootstrapped. Since the string interpolation syntax is simply a part of the HTML as normal text, the browser will render it as such. It will then be displayed for as long as it takes Vue.js to compile the template. Usually this happens only for a blink of the eye, but could vary depending on how fast a given browser downloads the Vue.js framework, among other factors. Perhaps you have noticed a brief flicker when we have been running examples within JS Fiddle. This flicker is caused by the string interpolation being displayed initially before being replaced by our data. To solve this, Vue provides a very useful directive named vcloak. When attaching this directive to an element, it will remain there until the Vue instance associated with the template finishes its compilation. So when the template is rendered and attached to the DOM, the directive is removed. This is very useful to us because we can then add a CSS style which ensures that all elements with the vcloak directive are not displayed. And when Vue.js is loaded up, the elements become visible because the directive is then removed from the elements. Let's see that in action. The example that I have added in advance simply renders a message data property within a paragraph. Since my browser already has the Vue.js framework cached, we won't even see a flicker most of the time. So to slow things down a bit, I'll wrap the Vue instance within a timeout function with a 5-second delay. So I will simply go down here to the JavaScript code and I can just write set timeout, which is just the JavaScript function. Pass in a function here and say 5000 for 5 seconds and move the Vue instance up here. Running the code, we'll see that the string interpolation syntax is displayed for 5 seconds before being replaced by the data property's value. Before running the code once again, let's first add the vcloak directive to the paragraph element. Since the directive doesn't take any expression or arguments, we'll just enter its name. So we can just write vcloak like that. Let's run the code again, but this time let's inspect the paragraph. Notice how the vcloak is added as an HTML attribute on a DOM element, but when the Vue instance is ready, it's removed. This is not useful until we add some CSS that hides elements with this attribute. So let's do just that. So I'll go up here to the style section and I'll say that elements with the vcloak attribute should have a display of none. So this is just to match any elements that have the vcloak attribute, which is a result of having the vcloak directive added. So let's run the code again and see which difference it makes. Now we no longer see the string interpolation being displayed initially, but after 5 seconds, the correct output appears. What happens here is that for as long as the vcloak HTML attribute is present on the element, it's hidden by our CSS style. And when the Vue instance compiles the template, it removes the vcloak directive and the element then appears. So the vcloak directive combined with a simple CSS style is used to hide string interpolation from the user, as it might not look so pretty to present this to the user until Vue.js is loaded. In this lecture, we'll be taking a look at looping through arrays, both with simple values and objects. We'll be looping through the data properties that I have already added to the Vue instance. One is an array of strings representing movie titles, and the other is an array of objects representing employees. In Vue.js, we can use the v-for directive for looping, so let's get going. First, I'll output the movie titles in an unordered list, so I'll begin by adding a ul element with one nested li element. So I'll say ul and li in here. And I'll just add a title here of movies. So the v-for directive renders the element that it's attached to 0 or more times based on its source data. Because I want to render one li element for each movie title, I'll add the directive to the li element. So here I can write v-for equals, and now for the expression. The v-for directive takes a special syntax. The simplest form is alias in expression. The expression is what we have seen before and can be many things, but in most cases we refer to a data property consisting of an array. In this case, we want to loop through the array stored in the movie titles data property, so we enter movie titles. So first for the alias, I'll say title, and then the keyword in and movie titles. So movie titles is the name of the data property, and title is an alias for each iteration of the loop, so each movie title. The alias is the part before the in keyword and is the name with which we can refer to the current iteration's item. We can use this for string interpolation to output each movie title, so let's do that. So within here, I can use the alias that I just defined, which is title, and this will give me access to each value for each iteration of the loop. So what this means is that the li element will be repeated for each item in the array stored within the movie titles property. For each iteration, we can access the current item using the title alias, and we output that using string interpolation. If I run the code now, we should see a list of movie titles being output. One could also have nested elements within the element that contains the v-for directive, as this element and any child elements are repeated as many times as the result of the expression. We have just seen how we can loop through an array of scalar values, so let's see another example which loops through an array of objects, namely the employees array. We'll display the employees in a table, and because the markup is quite verbose and long, I'll just paste it in so you don't have to watch me type it. And there we go. This is just a simple table that has nothing special about it. Within this table, we want to repeat the tr element within tbody for each employee. So that's where we'll be adding the v-for directive. So I'll add an empty v-for directive right here. And since we'll be iterating through a collection of employees, we'll refer to each employee as employee. So this is the alias for the current iteration's item. Then we'll use the in keyword to separate the alias and the expression. And the last part is the expression, which will simply be the name of the employee's data property in this case. So I'll write employees there. So for each iteration of the loop, we can now access the properties on the employee alias as we would normally access properties on an object in JavaScript. So here I can use string interpolation and I can write employee.name, which accesses the name property on the employee object. And I can do the same for the title property. So employee.title. Notice that the children of the tr element are repeated for each iteration of the loop as well, because it's the tr element that has the v-for directive. So any children of that element are repeated as well. Alright, time to take it for a spin. Now we see an HTML table displaying the employees from the employee's data property. Excellent. Not only can we access the current item in the loop, within a v-for block, we have full access to the parent scope, such as other data properties. To show this, I will add a new data property containing the name of an imaginary company. So I'll go down here, I'll say company name. I'll just call it Vue.js Limited. Notice that this property is in the root of the data object, and that despite of this, we'll still be able to access it from within our loop. I'll add a new header to the table and use normal string interpolation to output the company name. So first the new header, th company, and down here let's output it using string interpolation. And here I can just write company name. As you can see, there's nothing new here. It's just to show that you still have access to the parent scope within a v-for block. And as we can see, the company name is output correctly. As a side note, remember how we could use the HTML template element within the v-if directive for rendering a group of multiple elements without affecting the markup? You can do the same by simply adding the v-for directive to a template element, exactly as we did in the lecture on the v-if directive. With that, it's time to see how we can access the index of the current iteration of a loop. By slightly modifying the syntax within the v-for directive, we can gain access to the current index of the loop. The index starts at 0 and is incremented by 1 for each iteration. To show this, I have reused part of the example from the previous lecture and have added room for outputting the loop index within the employees table. To access the loop index, we need to modify the part of the v-for directive that contains the alias for the current iteration's item. We need to enclose this part within parentheses, first of all. So let's do that. Down here, I'll just add parentheses around the alias, like so. Then, following the alias, we need to add a comma and an alias with which we wish to refer to the loop index. In this case, I'll name it index, but you could choose anything you'd like. With this, I can simply output the index through string interpolation. So let's do that here. I'll just write index, so nothing new here. Running the code, we should see 0, 1, and 2 being output within the table, and indeed we do. Later in the course, we'll take a look at using this loop index to add a background color to every second row of this table. But for now, just know that if you ever need to access the current index of the loop iteration, then this is how you can do it. We previously saw how we can loop through an array of items. Something else we can do with the v-for directive is to loop through an object's properties. First, I will show you how to loop through an object's values. The syntax for doing so is actually the same as with arrays, so all we need to do is to give the current iteration's value an alias. So I'll begin by adding the v-for directive to the li element as before. So in this case, I'll name the alias value. Then we use the in keyword as we did before. followed by the name of the data property containing the object, in this case, person. We could also add a more complex expression, such as a method invocation, for example. The value alias will now contain the value of the object property for the current iteration of the loop. So now all we need to do is to output it with string interpolation. So I'll just write value here. And if I run the code now, we should see the person object's values being output in an unordered list. Now that was pretty easy, wasn't it? What we can also do though is to access the name of the property. To do this, we need to use the same syntax as in the previous lecture, where we accessed the loop index by adding parentheses to the first part of the v-for directive. So let's add these parentheses first of all. So the first alias within the parentheses is the value, so that part will remain the same. The second part is the object key, so I will name this property name. With this, we can now output this value as well. So I'll write it before the value with a colon in between, and I'll say property name. And this outputs a list with both the object keys and their corresponding values. Now you might be wondering why the second alias is not the loop index as it was when using an array within the loop. The reason for this is that Vue.js distinguishes between the type of value that we are iterating through and populates the values for the aliases accordingly. So the semantics of the various alias positions are slightly different when iterating through an object's keys. But what if we also wanted to access the loop index when iterating through object keys? Fortunately, Vue.js got us covered. This index is available if you add a third alias within the parentheses, so let's do that. So I can just write index here. And let's also output the index in parentheses after the object keys and values. So I'll write index here. And there you have it, an object's keys and values being output as well as the loop index. In this short lecture, I'm going to show you how you can output a range of numbers with the v-for directive. By specifying a number as the expression, the template will be repeated that number of times. So if I wanted to output a list of the numbers from 1 to 10, I would give the current number an alias followed by the in keyword and the number 10. So let's see what that looks like. So I'll add the v-for directive as usual. I'll say in as the alias, then the in keyword, and then a number. In this case, 10. So I'll just output the number right here. So what Vue.js does for us is that it loops 10 times and increments n by 1 for each iteration. And sure enough, we see a list containing the numbers from 1 to 10. This syntax also enables you to access the loop index in exactly the same way as you have previously seen. So let's just enclose the alias within parentheses and add index here. Now that we have the loop index available, we could do something like outputting n multiplied with index. I'll output both numbers as well as the result of the multiplication. So let me just format this a bit so it's easier to read. And I'll say n times and then index equals n times index. So the first part here is just for showing the calculation, and this will output the actual result of the multiplication. And as you can see, we now have access to both the range of numbers and the loop index, and we can do with those whatever we please. There's one thing you should be aware of in regards to the v-for directive. When Vue.js updates a list of elements that was rendered with the v-for directive, it uses a so-called in-place patch strategy for accomplishing this. What this fancy term means is that in case the order of the data items changes, it does not move around the DOM elements to reflect this. Instead, it will patch the elements and ensure that each element reflects the new item order, meaning that any string interpolation is refreshed accordingly, for example. In case that didn't make too much sense, then hopefully it will once you see the example that I have prepared in advance. It outputs a list of persons and allows me to either add a new person to the array or shuffle the items within the array. So let's add a new person. And let's shuffle the array. As you can see, the order of the items changes. So both of these actions manipulate the persons array. The implementation details of these actions are not important, so you don't have to pay attention to the JavaScript code unless you're interested in that. As you could see before when I clicked the buttons, Vue.js updates the list whenever I manipulate the array that the v-for directive operates on, and all is good. The important thing to note here is that it does not move the DOM element, but simply patches its contents. In simple cases, this is all we need, but sometimes this will get us into trouble, as you will see in a moment. How Vue.js detects these changes to the array is something that we'll cover in the next lecture. For now, you just need to be aware that while this behavior is efficient because it touches the DOM as little as possible, it's not without problems. Since Vue.js reuses the DOM as much as possible, this causes problems in certain scenarios, such as when using form controls that rely on the temporary state of the DOM. Let me show you an example of what I mean so that it's easier to understand. What I will do is that I will simply add a text input within the li element, which allows me to keep track of what happens with the DOM. So I'll simply add a new input here. And actually, that's all I want to do. So I'll run the code again. And now I have some input fields available to me. What I will do is that I will type in the name and the ID of the person that is rendered within each element. So here I'll write Andy 1, Abby 2, and Teresa 3. Now watch what happens when I click the shuffle button. The elements within the array are shuffled and moved around randomly. This is correctly updated in the DOM because Vue.js recognizes the string interpolation. However, notice how the text inputs were left intact and no longer match with the names and IDs to the left of them. This happens because Vue.js reuses the DOM for each of the li elements as a performance optimization. Clearly, this is a problem and can cause real problems in more serious applications than this. Problems that can be quite difficult to debug unless you are aware of this behavior. So now that we see the problem, let's see how we can fix it. This can be done by adding a key attribute to each element, which is basically a hint to Vue.js allowing it to track the identity of each element and thereby reuse and reorder elements correctly. We must bind the key attribute using the vbind directive because we need to specify an expression. So let's see what it looks like. I'll just clean this up a little bit. And I'll add the vbind directive here and bind to the key attribute. Most commonly, we will enter an expression that points to a property on the alias used in the v-for directive, which is p in this example. Since we must provide a unique value, I'll use the ID property. So p.id. It's important that we refer to a unique value such that Vue.js can distinguish the elements from each other. Let's repeat the test from before, and this time we should see that the input fields are placed and moved correctly in relation to the li elements. So I'll enter Andy 1, Abby 2, and Teresa 3. And let's shuffle. And you can see that everything looks good. The input fields are staying in the right position compared to the li element. And I can keep doing this just for a short while. And we should see that everything works as intended. While the default strategy that Vue.js uses results in better performance, you should be careful that you don't face similar problems to what we've just seen. For simple cases where you just use string interpolation to output data, it's perfectly fine to use the default behavior. But as you embed more advanced logic within your v-for block, you should start to consider adding a key attribute to your elements. At the very least, you should be aware that bugs like these may occur, and that if you see some strange behavior when using the v-for directive, then you should probably try to add a key attribute and see if it resolves your problem. This is really all you need to know. It's not that important to actually understand why this is a problem, as long as you know how to deal with it. Now it's time to talk a bit about how Vue.js recognizes when we change an array of items. In the previous lecture, we saw how Vue.js watches an array for changes and automatically re-renders the page to reflect the changes. Many of JavaScript's array functions change the array that you pass to them, instead of returning a new array. This is the case for functions like push, splice, pop, shift, and more. What Vue.js does internally is that it wraps these functions in order for them to trigger Vue updates as we would expect. Otherwise, pushing an element to an array, as in the previous lecture, would not work, for example. I have loaded up the example from the previous lecture because even though I told you that you didn't have to pay attention to the JavaScript code, there's actually something interesting to note. Notice the first line within the shuffle array method. This line uses the splice function to make a copy of the array that was passed as an argument. This is necessary because otherwise Vue.js will not recognize the changes that are made to the array. Now why is that? Isn't Vue.js watching the array, and didn't I just say that it wraps the functions to recognize when we change the array, including the splice function? Yes, that's true, but there's one exception to this. That is changing an element's value by using the square bracket syntax. Let's see a simpler example of that. So I've opened up a new JS fiddle, and in this example, we simply have an array of numbers from 1 to 5, which is output in an unordered list using the v-for directive. There is also a button which invokes a click event handler that changes the number stored at the second position to 10. What do you think would happen if I run this code and click the button? Let's try. As expected, we see an alert dialog with the new number indicating that the array element has indeed been updated to 10. But wait, the list has not been updated. Why isn't Vue.js updating the list now that it's watching the array for changes? This is actually a limitation of JavaScript, which causes Vue.js to not being able to detect when the value of an array element is changed like this. That is, using the square bracket syntax to update an element at a specific index. Yeah, I know this is really not so nice, but what can we do about it? As of now, we have two alternatives. One is to use JavaScript's array function to accomplish the same thing, because Vue.js wraps these and therefore detects the changes. Another is to use a method provided by Vue.js named set. So let's see how that works. I will replace the statement that clearly didn't work with a new statement, which invokes view.set. So here we can write view.set. And this method takes three arguments. The first is a reference to the object or array on which we want to change a value. This.numbers in this case. We need to prefix with the this keyword because we're inside a method on our Vue instance. The second argument is the key that we would like to change. Because we wish to change an element within an array in this case, this will correspond to the array index. In this case, the index 1. The last argument is the value that we want to set on the first argument, in this case, the number 10. Note that the reference that you pass as the first argument cannot be either a Vue instance or the root data object of a Vue instance. Running the code again, we'll see that the list is now updated as we would have expected in the first place. So in cases where Vue.js cannot detect changes made to your data, you can use the Vue.set method, and Vue.js will happily trigger an update to your Vue. In this lecture, we saw a limitation of Vue.js's change detection, but saw how to deal with it by using the Vue.set method. We have been going through a lot of theory in the past lectures, so now it's time to write some code in a few exercises. That was a lot of talking, right? Now it's time to take a moment to actually work with what we just covered. For the first exercise, I have added a password input field, as well as a password data property. I want you to use two-way data binding to update the data property with the value of the input field. The next exercise is about displaying the appropriate paragraph based on the length of the data property. The first paragraph should be displayed if the string is longer than 8 characters, the second if the string is between 1 and 8 characters long, and the third paragraph otherwise. As for the third exercise, please display the category names in an unordered list. Within each li element, you should add an unordered list with the names of the given categories, subcategories. Best of luck, and see you in a bit. I hope you managed to solve the exercises. Here are my solutions. The first exercise can be solved by simply adding the vModel directive to the password input, like this. And that's it. For the second exercise, I'll first add the vif directive to the first paragraph. So let's do that, vif. The expression is going to check whether or not the password property's length is greater than 8. So I can write password, which is my data property, dot length, greater than 8. For the next paragraph, I'll check if the length is greater than 0 with the v-else-if directive. So here I write v-else-if, and for the expression I'll write password.length greater than 0. By doing this, I know that if this evaluates to true, then the length is between 1 and 8. If none of this evaluates to true, then the length must be 0. So I can simply handle this scenario by adding the v-else directive to the last paragraph. Like so. Running the code, we can see that the last paragraph is initially displayed, and as we begin typing something in the password field, the text changes. To solve the last exercise, I'll first add a v-for directive to the ordered lists li element, because this is the element that I want to repeat. So I'll say v-for equals category in categories. So categories is my data property and category is my alias. For each iteration, I'll output the name of the category by accessing the name property on the object within the string interpolation syntax. So I'll simply output it right here. I'll say category.name. Within the nested UL element, I want to display an li element for each subcategory that the current category object has. Therefore, I will add another v-for directive on the li element. So again, v-for equals, and this time I will access the array of subcategory names on the sub property on the category object, and I'll use an alias of sub, which I can then simply output. So sub in category.sub, and for outputting it, I'll just write sub right here. Running the code once again displays an ordered list where each item has an unordered list, and with this we saw how we can nest v-for directives. Let's take a short break from talking about directives and turn our attention to something called computed properties. Computed properties are kind of similar to methods, but bring something powerful to the table: caching. Let's dive into an example and I'll tell you what you need to know as we go along. I have prepared an example which has a counter that we can increment by clicking a button. My full name is also output by invoking a method which concatenates my first and last name with a space in between. I have added an alert to the method just so we can see when it gets called. Running the code will show an alert, which is what we would expect because the name needs to be assembled initially. What's interesting is that if I click the button to increase the number, we'll see another alert. This is because methods are invoked every time Vue.js re-renders the template. As you can probably imagine, this is not very efficient in this case, because the getFullName method has nothing to do with the counter, and therefore it's a waste of computations to invoke the method again, since the result will be exactly the same anyways. The solution to this problem is computed properties. Computed properties are functions too, so we can simply rename the method's property to computed in order to turn our method into a computed property. So I'll do just that. I'll write computed here as the object's key. With computed properties, the Vue instance is also bound to the this keyword within the function. Computed properties are in the same scope as data properties and methods, so we can access them in the same way from within the template. In this example, I have to remove the parentheses because computed properties are used in the same way as normal data properties. So I'll go up here in the template and remove the parentheses. If I had left out the parentheses when using a method, then obviously I wouldn't need to change anything. I will also remove the get prefix from the computed property because we want to use it as if it were a normal data property. So I'll first do this in the template and then within the computed property name here. Let's see what difference it makes. So I'll run the code now. We still get the first alert as we would expect, but notice what happens when I click the button. No alerts anymore. This is because Vue.js caches computed properties based on their dependencies, meaning that Vue.js is actually aware of which dependencies our computed property relies on. A computed property will therefore only be re-evaluated when one of its dependencies change. In this example, the full name is assembled on the initial render. When I click the button, Vue.js is intelligent enough to realize that none of the dependencies of the computed property have changed, and therefore it uses the cast value. This means that the function is not invoked again unless a dependency changes, something that's much more efficient than the first approach that we saw, which used a method. Let's add a button which changes the name. So I'll go up here, add a new button. I'll say change name as the text and add a click event. I'll call a change name method, which I will add right now. So I'll add the methods object once again. And here I'll write change name and a function. And in here I'll just set the name to a different value. So I'll say Mark, and for the last name I'll say Gonzalez. Whoops, and I'll remove the space. And perhaps you already figured out what happens when I click the button, but let's see. So, nothing still happens when I increase the counter. But when I click the button that changes the name, we see an alert. As I said before, this is because Vue.js recognizes that one or more of the dependencies of the full name computed property have changed. Pretty cool, right? So Vue.js automatically recognizes when it can use the cached value and when it's time to run the function again. This improves performance, especially if the code is computationally expensive. Using computed properties is also a performance improvement when you need to perform the same logic multiple times within the template. Perhaps we want to output the full name multiple places on the page, so let's do that. So I'll just make a copy of this paragraph. Running the code, we still only get one alert because the second time the name is to be output, Vue.js uses the cached result. The same applies when clicking the button to change the name, also only one alert. Now had we used a method to assemble the full name in this example, the method would be invoked 2 times or as many times as the full name is used. This could quickly become expensive in terms of performance if the method did something a little more resource intensive than in this example. Also note that if I click the button multiple times, we do not see additional alerts because Vue.js understands that the values of the data have not been changed even though we assign a value, but it's the same value that we assigned before. So the value has not actually changed. Note that you can also bind computer properties to elements and do other things as you would do with normal data properties. So within the template, it's overall transparent to you that you're indeed working with a computer property. Generally speaking, it's good practice to use computer properties unless you have a reason for doing otherwise. We have seen how we can use computer properties to optimize the rendering of our page, something that's especially useful if you have some resource-intensive code that you don't want to be executed unnecessarily.